Hi everyone, today we want to learn the false color composite from the Landsat 8 and 9. The false color composite is an image processing technique that helps to highlight the specific features on Earth's surface by using the combination of different bands from satellite imagery. In remote sensing, false color composites are often used to differentiate between vegetation, water bodies, and urban areas. And in this video, we will demonstrate how to generate a false color composite using Landsat 8 and 9 surface reflectance data in a Google Earth engine, focusing in Lisbon, Portugal area. In a false color imaging, we use the near infrared band 5 for Landsat and appears as a red in the false color image, allowing for clear visibility of a vegetation. Red band 4 for Landsat is displayed as a green, which highlights the urban and build-up areas. And green's band 3 for Landsat is represented as a blue, which help to highlight the water body. This technique is widely used in a vegetation analysis, urban monitoring, and land use change detection. By combining the spectral information from this band, we can distinguish the various land cover, track seasonal change, and monitor ecological health. So yeah, we are going to step-by-step implementation. We define the area of interest like this. I define the variable and Lisbon areas. If you don't know how can create the bounding box, you can watch the related video in our channel. If you want this code, uh, zoom it on the Lisbon Portugal, and we need to define the time range like this. We specify the time range for the analysis to focus on the summer period, June to August 2024. This helps in identifying the seasonal change in vegetation, urban areas, and others. And after this, we need to select the dataset from the image collection. We use Landsat 8.9 surface reflectance collection available in a Google Earth engine, and this image are filtered by defined area of interest and the specified date range. And we also apply the cloud cover filter to select image with less than 30% cloud cover, ensuring the cleaner composite. We define the all with the filter bonds of area of interest, filter dates, and filter the cloud cover. And you can explore more from the F engine data catalog. Uh, and you can find this dataset here and dataset availability from 2013 until 2025 with the revisit interval 16 day. You can read the more about the description. You can find the bond name here, the pixel size, wavelength, and the descriptions. And after this here, we need to apply the scaling factor. In the Landsat, we have a scaling factor. Landsat data is processed with a scaling factor that converts the raw surface reflectance value to the corrected scale. The bonds near bond 5, red bond 4, and green bond 3 are selected for the false color analysis, and these bonds are then multiplied by scaling factor of this based on the description and adjusted by constant minus 0.2. And after this, we need to generate the median composite. We define the var, median equal to Landsat.map, apply scale, median.clip area of interest. The median composite is calculated from the scaled image. The median is chosen the reduced noise and cloud contamination, creating the more reliable representing of the area over the time period, and this composite is clipped to the area of interest. After this, we need to set the Visualization parameter like this, I define a variable visualization parameter 0 to 0.3 with this band 5, 4, and 3 near infrared red and green band with the gamma 1.2. We configure this visualization parameter for displaying the false color composite, and the near band will be displayed in red, red in green, and green in blue, and with the gamma correction of 1.2 to enhance the contrast of a image. And after this, the final step is adding on a map. We add the false color composite on the lives to the map to allowing us to visualize the result in a Google Earth Engine. You can see we have a good false color composite, and vegetation area you can compare with the base map has a red color, and urban area has a gray color, and water has a dark blue colors. If you're interested to other false color composites from other satellite like a Sentinel-2 and MODIS, you can find in the training playlist. In tutorial, we learned how to use the Landsat 8 and 9 surface reflectance data to generate the false color composite over the Lisbon, Portugal, and this method is helpful for analyzing vegetation, urbanization, and water body using the remote sensing data by applying the scaling factor, filtering clouds, and creating the median composite. We can obtain the clear and more accurate view of Earth's surface. You can use do this method to monitor land use change and assess vegetation health and explore environmental changes over time. Thank you for your watching. Please like and subscribe our channels.